Okay, so today is Thursday, the 8th of December, and welcome to today's Tech Hour. The topic is Scalable Vector Graphics, a rough survey, and it is going to be a rough survey. I promised that I would say a few words about accessibility, so I'll do that right from the beginning. And there are three topics I think that are important for accessibility. Three topics. The first is keep the caption linked to the artwork all the way through the workflow. That's a sort of problem. And one example of that problem is you're writing a LaTeX document. When I say the caption, I mean the caption for accessibility purposes, the alternative text for the person that can't see the caption. And as far as I understand at LaTeX, it's quite difficult at present to provide that extra information which doesn't appear in the typeset version, but it's definitely needed in the document to convert the thing into accessible, available in some way to produce that. And it struck me that from my experience in the Open University, that often you have a graphic that's drawn for a particular purpose. And the graphic might exist in terms of here's a drawing and here's a description to the artist as to what should be done. And that description might be useful when it comes to providing the alternative text. But if it gets separated through that whole process, then there's a problem. That's the first thing. The second thing, which is something that sort of annoys me and I don't know how to solve, is that often you see screenshots of console output on programming websites, and the screenshot is completely opaque unless you can see it. There's no way of copying and pasting it or anything else like that. It's just a bitmap graphic. And I don't know how to stop that happening, but I do think it would be possible to recognize such graphics as being screenshots of console output, because the OCR would work quite nicely on them, for example. And then at least you can warn somebody that something's gone wrong when the thing is accessibility checked. The third thing is, I'm going to blow my own trumpet. I created a service called Mathtran that created bitmap images, PNG images, on the fly, running tech as a daemon. And I did two things. Into the bit, I made the graphics both scalable and editable. And the way I did that was I put the text source for the formula, maybe it's the quadratic formula, I put the text source into the graphic as a piece of extra information. It's there, you can read it if you want, it doesn't affect the display. And I also put the typeset output into the source, again, as something that can be read. So assuming you had a suitable tool, you could open up that graphic and view it as a DVI, which is by definition scalable. And you could also have the text source, which makes it editable. So even if your workflow uses graphics, if you put into the graphic extra information that continues all the way through, that will allow you to, so to speak, it'll be a bit like a dog tag, which means that the object is identifiable even if it's lost. So you can keep the link between the graphic and the various resources that went to create the graphic. So that's a little bit about accessibility. I think there's a lot more to say about accessibility, and perhaps we'll have some opportunity to do that later. I'm going to give you a brief overview of what's happening. The first thing is I'm going to say what questions to ask. That's the first thing I'm looking at. Then I'll give a brief history. Then I'll compare paper with browser, and then we'll start doing case studies. And the first one, if that's all right, will be Doug. So that will be Doug will have an opportunity to share a screen. And the others I've highlighted are TIX PGF, Asymptote in GeoGebra, Vega, and PIC. And then the final thing is conclusions, which is, roughly speaking, has the exercise been worthwhile, and where do we go next? So first of all, what questions to ask? Well, I think that's the first question: is what are the right questions to ask regarding graphics? And I've got a couple to put down. What knowledge to acquire? What knowledge do we as individuals or a community need to have, or already have? If we don't have, we may already have knowledge. If somebody comes into this area, what knowledge do they need? So that's a bit like an outline FAQ. And the second thing is, what are the problems, if any? What are the problems we're trying to solve? And for that matter, what are the problems that we have solved? So a brief history, and I think we could probably start with the oscilloscope. So the oscilloscope is a way of studying electrical circuits. And you get these nice sine waves that make these nice noises, and you get sawtooths and so forth. And they're oscilloscopes are very, very important to electrical engineering. And you can sort of see noise in the signals in oscilloscopes. Now, what you've got there is you've got a moving point going across the screen and up and down. So it's going across the screen and up and down, across the screen and up and down. Now, so far, so good. That became the television. With the television, you had a line that went across, and it went back, and it went across, and then it went across. This is the old-fashioned televisions that sit in a big wooden cabinet, the ones that you had in the very late 30s and the 40s and the 50s and the 60s and the 70s. And they were sort of glorified oscilloscopes. They were sort of raster devices where you got a line running across and its brightness varies, and then a line runs across and its brightness varies. It's like curling a lamp around at high speed, and you get the appearance of a circle of light. And the early printing devices, in fact, all printing devices, including the laser printer, are raster devices. So you have a photocopier, which is another name for a laser printer, really, scans the image line by line by line and prints it line by line by line. And when the whole thing is printed, it gets transferred onto paper through the wonders of electrostatics and photoconductivity and so forth. So for the computer monitors we have are also raster devices effectively, although they're individually accessible. Each pixel is, so to speak, individually accessible, and they appear to change all at the same time. So they have a 60 frames per second refresh rate. Now, I'm going to start with Metafont, which is the program that Don Knuth wrote for designing his fonts. Now, a vector graphic is where you draw a thin line and you close up the loop and then you fill the loop in. So it's a bit like a silhouette. And if you look at a letter on the computer screen, and you make it very big, it looks jagged because the screen isn't perfect, but it's ideally it's a line like a triangle, and one side of the line is one color and the other side of the line is another color. So that's, roughly speaking, what vector graphics are about. And with vector graphics, you not only have lines, but you also have curves. And there's a lot of mathematics associated with these curves, which goes way back, at least to the 19th century, with numerical analysis and approximation of functions and computing power series, Taylor expansions, and all that stuff, if you know the calculus. Now, what Don Knuth did with Metafont was he built a system for designing fonts and turning them into raster fonts, because that's what he was printing with. There weren't any outline tools existing before he did his work. So his output was all bitmap because he needed bitmap. And he actually introduced nibs. He had nibs of various widths and shape to mimic the calligraphy or pen writing that in some sense was the basis of the fonts all the way back to Gutenberg. Gutenberg based his fonts on German black letter writing, and Aldus Manutius introduced italic based upon the italic hand of writing. And with Knuth's nibs, as the nib goes round the curve, so a different part of the nib is, so to speak, the one that cuts the boundary edge, which is quite sophisticated. That's by and by. So we've done Metafont, we've done image setters. PostScript was a language that made image setters. Now, Doug will correct me and perhaps can chip in if he wants to. PostScript was a language that allowed image setters to be really useful, because image setters have a high resolution collection of zeros and ones. And you have to describe which zeros and ones are black and which ones are white. And you can't do that. It's not practical to do that on the output, in the software that's creating the page. You let the image setter do that. So you run something on the image setter that turns an outline image into a raster image, which is the only thing the image setter can actually produce. Because it's of such high resolution, it looks like a smooth curve. Just as the old-fashioned cinemas were frames going cellular, frames of cellular being displayed in rapid succession, but it looked like a smooth motion. So the PostScript engines, as I understand it, were adopted by image setters in the same way that the ARM chips are adopted by mobile phone manufacturers. And that was the making of Adobe and Warnock's technical financial success based upon technical excellence. Nelson knows a lot about this too, because he lives in Utah, which is where Adobe are based. So out of PostScript came PDF, which I believe is in part related to the rise of personal computing and the need to produce PostScript in a form that people could share, so that not only could an image setter print PostScript, but an ordinary PC. Then the next thing was HTML, which was in 1993, which is when PDF came out, a fairly baby-like thing, and you wouldn't talk about typography when you talked about HTML at that time. It had no typography. It had these things called, that had a marquee element that produced a banner that went across the page. That was an official element of the thing. It was quite vulgar, and we didn't have cascading style sheets at that time either, I think. So HTML was a very crude baby at the time when PostScript was ruling the roost and dominating everything. But as time went on, HTML became more important. So PDF came in, then HTML, and SVG was developed by the World Wide Web Consortium, the W3C, and I think it was released in 2001. So that's the vector graphic format that is most appropriate for web pages, just as PostScript PDF is the vector graphic format that's most appropriate for sending things to print. I'm now going to compare paper versus the browser. I'm not going to compare PDF with HTML. These PDF and HTML are media in their own right. When I'm talking here, I'm talking with my voice, which is, if you like, already a medium. It's going through the air, which is another medium. It's going into my microphone. It's going through all the internet and everything like that, and coming out at the other end. So there's a whole bunch of media there. And I'm not interested in HTML. I'm interested in the browser or the computer monitor. And I'm not interested in PDF. I'm interested in paper. So I'm comparing those two media. And I just made a list. The browser is interactive. Paper isn't exactly interactive, although you can write on it, which is pretty good. I much prefer to do crosswords on a piece of paper. Paper has high resolution. High resolution is very cheap with paper. It's expensive on browsers. Browsers are very colorful. They have color, but they don't have high resolution. I remember when color photography came out, and it was color photography, but it didn't have the resolution, didn't have the fineness of detail that black and white photography has. Some people prefer black and white photography because the photograph is an image of reality. It's not reality itself. And by the image being black and white, you see that it's an image and not the reality. Paper is, at least traditionally, archival. Libraries kept books safe. You signed a contract in order to make a binding agreement. And paper is, well, I say traditional. And the browser is innovative. So the choice between paper and browser depends on lots of causes, lots of factors. And I think it's wrong to say that. I think it's best to recognize that each has its strengths and weaknesses, and that for certain services, which is best? The answer is it depends on what it's for. One example of this is road signs. Road signs are, roughly speaking, print medium. And we like to have real physical road signs rather than, so to speak, electronic road signs when we're driving. Although we do have electronic road signs in the form of satellite navigation, so we have both. So, gosh, I've spoken for half an hour almost now. Perhaps I can put Doug on. But before we do that, are there any questions or comments at this point?
In your history, you didn't mention radar scopes.
Oh, that's a good one.
And the reason I thought of that is because, my dad built his own TV when he was a teenager in the 1940s late 1940s out of spare radar parts that he got surplus from the military. So radar was also I guess a vector medium, I suppose, as well. There was actually artwork that was done on oscilloscopes. They were called oscillons in the 1950s, I think. My dad and I, when I was a kid, we built an oscilloscope. And we also, when I was a kid, I built a harmonograph, which is a device for creating complex Lissajous figures with mechanical pendulums. So there's, anyway, there's a lot of different ways to pull a pen or something that emits some kind of ink around in a medium that is not rasterized. There was another thing you said. I'm not sure I agree completely that Knuth was the very first to use nibs. Maybe it was, but they were teaching splines in computer science courses in the mid-70s. I know that at IBM Research in 1980, where I worked for a year, I wrote a font editor, which was all bitmap. And so it could do circles and so forth. I don't think it did splines, but in any case, it would have rasterized everything, and everything was stored as a bitmap for their experimental typesetting machinery at the time. The other thing that you said that I had a thought about was, you said paper is high resolution. That's true for maybe for the average or above average case, but in my case, for the kinds of things I need to present to people to look at, as I'll show in a minute, paper is not sufficient. So,
there is somebody who printed a piece of paper with the world's largest prime number on it, largest known prime number, and you could send some dollars and get it. And he kept on doing this for quite a while. and he had to refine his printing technology quite a bit so that it would still fit in a reasonable compass. But you would need a magnifying glass to read it.
Right, but
Nelson,
the resolution is dependent on the kind of fibers you're using to make the paper. So
yeah,
you could print it as a micrograph. You know, I mean, you could do photomicrographs or any of that. But so it's always dependent on something or other. But in my little world, resolution needs to be infinite.
yeah. Talking of resolution, I think it's called photolithography that is used to create the screens that are used for the computer chips. And prior to that, photolithography was a printing process. Nelson.
Yes, perhaps I could toss in some history here that may be unfamiliar to some of the participants and viewers on the web. John Warnock, who was the co-founder of Adobe Systems, had gotten his undergraduate bachelor's degree and his master's degree in mathematics in my department, and was slated to get his PhD, but then his advisor was hired away by another university. He was faced with moving and having to take courses over again, or changing to a new advisor. And he ultimately decided to stay at Utah, but to switch into computer science and electrical engineering, thanks to the support of Dave Evans, who was the chair at the time of computer science. As soon as John graduated, which he did by working on a hidden line algorithm for computer graphics, he joined Dave's company, Evans Sutherland, which is in our research park area adjacent to campus. And within a year or so, tootled off to Xerox, met Chuck Geschke, with whom he later founded Adobe Systems. And they were very keen on the idea of a programming language that could describe essentially any two-dimensional image ever created by humans, including all of the world's alphabets and printing systems. And they saw a considerable future in this. They tried to convince Xerox that this was the right thing to do. But Xerox said, but this is an interpreted language. We can't possibly drive high-speed printers, which was true with the technology at the time. But John and Chuck felt strongly enough in their ideas that they went off and founded Adobe Systems, which John told me was named after the creek in his backyard in Palo Alto. And they set up a backroom development of both the PostScript engine as well as a laser printer, which was done for Apple, the Apple LaserWriter, which appeared in 1985, as I recall. The HP LaserJet appeared a year before in 84. In the 90s, I was asked by Adobe to join a team of academics to form a short-term advisory council about this new technology they were developing, which we now know as PDF. It had a code name in those days. But one of the driving forces for this was that PostScript, being a programming language, could have functions, and functions could call functions. And so you could quite easily arrange to take arbitrary amounts of time to render a page. And there's a nice benchmark program in PostScript that will render any numbers of thousands or millions of bubbles, overlapping bubbles on the screen, and you can make your printer spend days before it can print it. In any event, the driving thing here was that PostScript had two problems. One was the fact that programs could run an arbitrary, unbounded amount of time. The second one was that due to the memory limitations of computers at the time, and printers as well, that you couldn't download all of the font resources and any other image resources like watermarks and company logos and so on at the front of the job. You had to essentially deal with one page at a time, download the fonts for that page, and then essentially delete them and move on to the next page. The result of this was you could not jump into the middle of a PostScript file, even if you know where each page began, because it could conceivably need resources that were defined in earlier pages. So a strong motivation for PDF was that every page must be independent. There must be a directory at both the beginning of the file and the end of the file. Now, of course, when you're producing it, you can only produce that page directory at the end. But Adobe produced a feature in Acrobat Professional that was called optimization, that made a copy of that directory at the beginning. And the reason for doing that is if you want to view the PDF file of an encyclopedia of thousands of pages, you want to be able to start reading page 20 long before the whole encyclopedia is downloaded, and with the directory at the front, you can do that. So that's kind of the background of the motivation for PDF. And Adobe recently announced, just within the last month, that future versions of their software will drop support for PostScript fonts, at least the Type 1 fonts. And it's clear, I think, in the industry that PDF has won, because PDF, although it's kind of a subset of PostScript in many ways, in fact, the interpreter started out that way, it is not programmable. There are no functions you can call, and there's no recursion. And so pages have a relatively quick rasterization time, and that was important if you were going to drive a 500-page-a-minute printer, which IBM had one device roughly 20 years ago that had 24 CPUs rendering pages in parallel, each of them getting a bitmap ready for the next page to come off the printer. And this is obviously of enormous importance in, say, the newspaper industry, where you have to drive presses at tremendous speeds with tremendous amounts of text on them. So that's some background in PDF that might not be obvious to people who haven't delved into the technologies. But I'll pass the baton over to Doug, because he's going to tell us something interesting about SVG and the work he's doing.
Before we put Doug on, I'd like to thank our two expert witnesses, Nelson and Dirk, for giving some of the history, and I think showing the importance of the questions that were being asked. That Adobe started by asking questions or setting out problems, and the choice of the problems was extremely important. So over to Doug, and I have to allow screen sharing, which I'm not quite sure how to do. Settings. No, it's participants. Doug, I've made you a co-host. That should allow you to do everything I can, which includes sharing your screen.
All right, let me figure this out.
Hooray!
Looks good.
Okay. I'm not gonna, well, let me just quickly post. Oh, I don't have my, I can't get to the chat on the Zoom anymore. Anyway, I'll get back to the chat and post the URL for this. Let me get this up. Okay. So for a couple of years now, I've been selling an electronic book for iPads. It's not so great on iPhones, but it'll work. And now it works on iMacs. And it's a self-typesetting book that has its own tech interpreter, which is not the usual tech interpreter. It's one I spent several years writing. So it self-typesets. And the problem I have is that my expertise is in what are called space-filling curves. And these are paths, self-avoiding paths in the plane that can have, you know, tens of millions of line segments in it that I want to be able to zoom into. And as just a quick demonstration, let's go to page 56. All of these illustrations are interactive. So when the tech typesetting, I had to completely do an end run around PDF. There's no PDF in this at all. And the reason is because PDF, as Nelson said, does not have procedures. It doesn't have algorithmic aspects to it that PostScript does. In PostScript, you can write recursive algorithms really easily. And in my work, I've got a whole PostScript library that's, you know, production rules and recursion, this and that. And PDF just blows up, and you have just an enormous amount of floating point data. Let me show you. You know, I want the user to be able to zoom in, all resolution independent, and look at the details and color in and do the usual things that you can do with PostScript paths, which you can also do with the basic core model of drawing things on Apple's technology. But, you know, I'm also interested in variations of things of that, like the Hilbert curve. So, for instance, here's a path that's 92 squared line segments. Most of them are collinear, which has the property that you can plug it into the exact same algorithm that draws the Hilbert curve, and it will create a fractal tile with 71 million sides. So you saw how that sort of filled it all in, but this is all resolution independent. I need to be able to zoom in and be able to play with this stuff graphically and scroll around and see what the patterns are. So I am unconvinced that SVG is going to be helpful for me in this situation, because here what I'm doing is I'm using, you know, Apple's core graphics to algorithmically do the same thing that a PostScript program would do. And it's about as fast as possible. And Apple has a lot of nice technology for doing interactive zooming without losing, you know, your user interface. But with SVG, as I understand it, and I don't completely understand it, you would have to build in memory this 71 million long SVG string or whatever, and then present it to the renderer, which kind of duplicates the work in a lot of ways, and which uses up twice as much memory, because the renderer is going to have to record everything before it can fill it in as a polygon. So that's my problem with SVG and PDF. And this book was, you know, I basically had to write my own tech interpreter in order to produce this book, because I couldn't use PDF. And, you know, yeah, I could have hacked together maybe a DVI version of the book without any illustrations and rendered that and filled in the illustrations at all. But I'm sort of I have a long-standing interest in implementing computer languages. And long ago, I actually implemented a PostScript 1 interpreter. So that's the, you know, kind of the, you know, that's sort of an overview of my problem with vector graphics and how I'm trying to, you know, build an interactive document that solves the problem of the particular types of things I want to illustrate. So that's kind of an overview of the book. I'll post the URL for this in the chat. And I'm not interested as much in presenting this as a bunch of web pages free for the world. I'm more, you know, it's a lot of work. You know, I charge $8 for the book, and I sell it through Apple's store, and you know, I don't make a lot of money from it. But you know, there's a lot of other interactive textbooks that could be made this way. There's a lot of other technologies, or, you know, other topics that might benefit from this kind of melding of a computer program within the actual document. So in any case, you can take back your screen, Jonathan.
Yeah, I don't have to take it back. If you just release the screen, then we're into standard mode.
Stop share. Okay.
How's
that? All right.
Did you say it runs on all Apple products?
It runs on iOS machines, and it runs on ARM-based Macs. What I want to say is there's a tremendous problem, partly with my subject matter and partly with the technology, for accessibility. I don't know how to, you know, I don't have a printable version of this book except one that's second rate compared to the interactive version. So, you know, these are really tough problems to solve.
Would it run on an iPad?
Yes, it was originally for an iPad, because some of the Apple's got bugs like in the page turning graphics and so forth that don't work on Intel Macs, or maybe they do now, but it was a less than a week's worth of work to port that program to the ARM-based Macs. Thanks to Apple.
So the essential thing, as I understand it, is that you want interactivity to trigger real calculations, not menu type calculations. You're muted.
All of those illustrations are either C programs or C subroutines in the app, or they are, there's a baby PostScript interpreter in there, which partially interprets EPSF files that are part of the distributed app. But that app is about 5 megabytes in size, in spite of the fact that it has all of the text source code for the book in it, as well as no PDF. If it were all PDF based, which is resolution independent, some of those illustrations would be 100 megabytes. I mean, the entire app would be 5 gigabytes in size, and that's not distributable even today. So, that's why I can't use PDF. I'm not sure I could use SVG.
Okay, I think SVG is not buttoned down in the way that PostScript PDF is, at least if you're allowed to use JavaScript. And there's a refinement, if you like, of JavaScript called WebAssembly, which can be compiled to native code that runs reasonably close to native performance. So that is quite possible. I'll show you. I'll demo something there when I get the screen back.
You have
Philip has bought a copy of your book. I claim my 5% commission.
Where's your tip jar?
Any more comments or questions? I think it's very impressive what you've done.
Yeah, I've given a demo of it to Don Knuth, and I've also given a demo of an earlier version of it at TUG, maybe 5-6 years ago. So, and I have lots of I've got tons more to write about, but I'm currently rewriting my tech interpreter for some curious reasons. But so
there is a sort of fairly widespread equivalent to what you're talking about going on, which is Overleaf is one example, and Jupyter Notebooks is another. I'll talk about Jupyter Notebook. There you have a sort of scientific notebook which has a computational kernel behind it. And Jupyter Notebooks allows you to run that kernel on a server. And what you've got is the browser is acting as the display device, and then you've got a server doing the computation, which is the same model as you have for Overleaf. And it's fairly close to the X-Windows model, where you have a server doing the calculations and you have a console or some other view on what's happening. So the display and the computation are separated and networked.
Yeah, and at one point, I don't know what the status of it is, but Wolfram Research they were trying to come out with CDF, which was computational document format. And, it was a means of incorporating some portion of their Mathematica engine into a renderer for documents, but I don't know where that went.
There's something I saw a couple of days ago, which is a proof assistant, which allows you to interactively create real mathematical proofs. And when I say real, I mean they can be verified by a computer. And you can actually access the system and access some exercises on this system through the web browser. And when you do that, a Docker image starts and provides the computational engine. So there's a real tradition having a computational engine separate from the display engine. And with WebAssembly, the computational engine can be in the browser or on the local machine rather than on a remote machine. And I think that's where a lot of stuff is going nowadays. So a document will consist of a display and text, and also the computational. So instead of having graphics, you have computations available. You have a computational program. What's the word? You know how you can sort of view a 3D graphic and rotate it and stuff and fly through it, and that's fairly normal now. But with the technology we have now, we can do the same sort of thing, but it's not a 3D model that you're exploring. It's a piece of software, a fairly generic, and more or less any piece of software you can deal with in that way. And I think that's got something to do with the future of publishing. You know, there was a time when high quality photographs were special and expensive, and you'd have books with sewn signatures, and you'd have a signature that had the photographs in it. All the photographs were kept together because it was cheaper to produce, because they needed special paper to be printed on. And nowadays we can sort of use the browser as the computational engine.
Well, there's a whole push to get away from apps entirely, except in your web browser. So, especially with WebAssembly. So, I don't know quite what to do. If anybody's going to make money off of this stuff, they're going to have to paywall the app somehow. But anyway.
Okay, well, making money is one of the concerns, and Adobe deal with the print industry, whose business is, if you like, making money. And because they're making money, they don't object to paying money to Adobe to support their business. Whereas if you're making software for hobbyists, well, hobbyists won't pay you much. Perhaps you'll get tips. You'll get some tips. Let me do some presenting, if that's all right. Have I missed anything from chat? Okay, so more. Share screen. Okay, so you should be seeing a TIX device page. And are you seeing the TIX PGF packages manual?
Yes, that's fine.
Okay, so I'll start. Although I don't use it very much and I don't do many pictures, I am very impressed by the architecture of TIX and the community around it. And there are a lot of things I like about it. What you're looking at now is something that really surprised me, which was that the TIX documentation has been converted to HTML, because I've only known it as PDF documentation and I've not particularly liked it. And then the other thing that's a very nice surprise is that it uses Michael Dunn's LWARP package, which is also quite highly regarded. It's a LaTeX to HTML translator. And if I click on these things here, you can see that there's been quite a good job at making something that's navigable and so forth. Now, TIX is architectured in a way that I think that neither PostScript nor, well, maybe that's a bit wrong, hard, but PS-Trix are architectured. And it has some attempt to be independent of the output device in the same way that text DVI that Don Knuth introduced, the DVI file format, is independent of the output format. And looking at this, and also this document from the R community, where R is a statistics package. That's the famous bell curve in the top there. The statistics package is very widely used. It's very good with accessibility, and Jonathan Godfrey would not have had his career so easily or less hard if it wasn't for R and the community there. And they have incorporated, they have produced adapters, if you like, that allow it, make it straightforward to use ticks from within R. So the ticks source code, the source code for ticks pictures is being generated as is being used as a back end for the R graphics. And this is all very interesting and outside of my field of experience and expertise. But it's a clear indication to me, I think, of what's going on and something that's working successfully. And I didn't realize that these capabilities of ticks depend very, very strongly on DVI SVGM, which is a translator of DVI into SVG, which was the precipitating cause for me organizing this meeting, because DVI SVGM was having problems because GoScript, the open source variant of PostScript, no longer provides the same capabilities as before. And the capabilities that have been removed are because they're no longer using PostScript as their renderer. They're using a custom C renderer, which makes us go back to why was PDF introduced in the first place, as Nelson told us. And which in some sense was to give a finiteness of computation. And the reasons why the GoScript are dropping the old PostScript style renderer is for security and performance. And then the final thing is skills. The skills required to manage PostScript are getting weaker and weaker. There's a concern that the software will become unmaintainable, I think, because people don't know how to do it. I heard some time ago there are people that make quite a good living maintaining APL software. APL is an old programming language, and if stuff's still written in it and it's being used, then it needs maintenance. So I'm putting that down as one of the important examples of technical graphics. And I'm going to talk now about another one, which is called Vega, which is a visualization grammar. I'll just read out from the web page. Vega, I'll make it a bit bigger. Vega is a visualization grammar, a declarative language for creating, saving, and sharing interactive visual designs. Now, a declarative language means you write down what it is you want. You don't say how to do it. That's roughly speaking what it says. So you make enough true statements and then it's finished. And in some sense, Metafont has elements of that, because the Metafont software includes a linear equation software where you say these are the constraints between these points, and then it will satisfy those constraints. And it says that Vega provides basic building blocks for a wide variety of visualization designs. Now, this is a higher level of abstraction. We're talking about designs that are used to build visualization. So it's a sort of patterns in architecture. You know, the spiral staircase, the landing, the front door, the porch, all these are patterns in the sense of Christopher Alexander in architecture. And Vega seems to provide the grammar, if you like, for doing all of that. So this is very common in the realm. This is very popular amongst Python data, Jupyter notebooks, that sort of thing. So there's that, there's Vega, there's Asymptote. I don't know much about Asymptote, and I don't know if I've got my page anywhere. Let me, come on. Come on. So I'm trying to drop a picture. Sorry. Dwight Appleditch emailed me before the meeting to say that he regretted that he couldn't come because he's traveling, but that he does a lot with PIC. So I'll bring this up. So PIC is a domain-specific language by Kernighan, one of the founders of Unix. And it's a little language for writing graphics. And well, Dwight Appleditch's implementation DPIC can generate PDF, PostScript, and SVG and other images, as well as a preprocessor producing several LaTeX compatible output formats. So Dwight is being very modest here because he sent me this stuff without saying that he's the author of DPPIC. But so this is DPPIC, and I'm getting lost here. So this is a small language that's quite influential in its time and is still being used. And I think that's one of the examples we should know about. And if I can get asymptote up. Here we go. So asymptote is a vector graphics language. And here's an example of asymptote code. So this isn't declarative, it's procedural. And it says, put this here, put this here, put this here, put this here. And I was surprised to hear that it's used by GeoGebra, which is an computer algebra system that is widely used, at least in the Open University 10 years ago, for teaching. So languages that work for teaching, graphic languages that fit well with teaching are important. And there's one more thing I want to show, which is, I'll put the URL into the chat if I can. I can't. This is the Mandelbrot set, and it's been programmed a bit like Google Earth, so I can zoom in on it. Come on. Why is it not showing? Okay, so this is sort of recursive in the same sort of way that the space filling curves are recursive. So this little bit here looks like the big thing. And if we zoom in on that little bit and zoom in again, and zoom in again, and we've got something else we can zoom in on here. And again. And we've got another one here, and we've got another one here. So we'll zoom in on this one here. I hope you're getting a satisfactory experience through the. Okay, so we're now zooming 124 times, I think. Yeah, 124 times. And this has at least some analogy with what Doug was so kindly showing us. So at this point, I'm going to stop sharing.
Was that Mandelbrot set being computed in the browser?
Yep.
Okay.
You've got to be careful. People start computing cryptocurrencies in your browser if you let them.
I've also got a similar app on the iPad, but I don't know if it's actually computed on the fly or if it just has up to a certain resolution stored. I don't know, but it works the same way. You can just zoom in however you like.
Completely off topic. There's a remarkable algorithm that will compute the 3 billionth digit of pi, the 3 billionth binary digit of pi, without computing all the intermediate ones.
Computes it in hex.
Sorry?
It computes it in base 16 in hex.
Yeah. Well, 2, 6 is yeah. So we've gone over a little bit over time. People can stay if they want to, and I'm very pleased with the discussion we've had because I think we've covered a lot of ground. And I'll just remind you of the questions I wanted to ask, which is, what are the questions to ask? What knowledge do people need in this area? What are the problems, if any? And I'm just happy to take contributions. Just put up your hand or just talk out and say, I think such and such, or I would like, or I don't know how, or I think. All opinions are welcome.
I mean, you know, one of the problems with my ebook is that it would be great to sell to students, but I don't have a version on other platforms besides the iPad or the Mac. So it's not, that makes it unrecommendable by teachers. And one of the reasons is, you know, on Android or whatever, you have to program in Java or Kotlin, and again, the graphics model there is much more, they're much more attuned to SVG than Apple's core graphics, which is basically, I mean, yeah, they all do paths and so forth, but I haven't convinced myself that I'm going to be able to do the same thing interactively in as nice an interactive way on Android as I can on the iPad or on the later Macs. So that's one of the problems I struggle with.
So you would like to see a good example showing that what you want to do for yourself can be done?
Sure. Yeah. I mean, I've actually, you know, you can, my tech interpreter is just a C library, and I created a Java wrapper around it so that I could call it from Java. So that's okay, but that's actually a secondary programming problem for me. My main programming problem is the illustrations. So anyway, I'm not an experienced Java or Kotlin programmer, and I but what I understand is that the drawing model is SVG based, and I'm a little worried about, you know, using up too much memory to render something as SVG and then giving that to, you know, the Java graphics system, which has to do exactly the same thing internally. So that means you double your memory. Anyway, so that's the only thing that I spend my time thinking about with respect to this stuff.
Could you have a version of your book on a server and have people access it over the web, but do all the computation on the server and just throw the display at a browser?
Yeah, but when an illustration has 71 million line segments in it, that's all, each segment is, you know, 4 to 8 floating point values. It's not, you lose your interactivity. I mean, you know, we just watched a fairly choppy rendition of the Mandelbrot set on the web browser, and that's not a lot of fun doing that, just waiting there for little tiles to render.
Yeah.
In the long run. Apple's got interactive technology for zooming that's really top notch, which is how I'm able to zoom in, and it actually gets more interactive as you zoom in.
So you know the Apple platform pretty well, and you can use it, and it does what you want, and you don't even know if the Android platform has equivalent functionality. Muted. Thank you.
Correct. I mean, it might have 80% of it, but in my case, I actually wrote a quadruple precision program for Benoit Mandelbrot to explore what would later become the Mandelbrot set. And he used to justify his work at IBM Research by going to the head of IBM Research and saying, all of this stuff I'm doing is pushing your technology to the limit, both figuratively and mathematically. And, that was his way of justifying his fractal research at IBM and it was true. I mean, it just pushed all the graphics machinery and everything to the limit. But, you look at your web browser zoom in there and it's not a lot of fun compared to, because it just is so choppy. And if you look at my iBook, it's a little bit choppy, but not nearly as much. And it's got, several orders of magnitude more information per image in it. So what I'm worried about is on the Android, it's going to be a bad user experience.
I'd like to introduce one of my wishes, which is I'm in favor of diversity, and I don't like fragmentation. I don't like the community to be fragmented, but I do want the community to have a lot of diversity. And I fear that the people that specialize in PDF don't know enough about what's happening with SVG, and the people that deal with SVG don't know enough about what's happening with PDF. And somehow I feel that there's a lot of reinvention of the wheel and technologies not being adopted when they should be. So I think it would be really great if a small tech and associated graphics were available to run in the browser. And then the people for whom the browser is number one will have a first-class platform for typesetting mathematics available to them, even though it's being done in the browser without any thought of PDF. And similarly, the people that do HTML understand CSS very well, and CSS works very well, and it's very widely used. And there's even software for generating CSS that works well, that takes a lot of the hard grunt work out of it. And a lot of thought about how to make things efficient and transparent. I don't mean transparent in the sense you can't see them, but the clarity in terms of the relationship between code and behavior. And I think that being able to style tech documents using something like CSS would be a great benefit. Being able to style print documents using something like CSS would be enormously valuable, because people know how to use CSS and it's a good piece of technology. So I'm concerned that the diversity of the community should not lead to the fragmentation of the community. And that means, in a certain sense, talking to people who aren't like you, talking to people who are web developers rather than, or user experience people. So welcome, Shamsi. We're really glad you're here. So that's my general concern. And I think my specific concern, actually, I want to understand TICS better, because I think I could learn something from it in terms of how tech macros work and don't work. I'm going to stop, and maybe Shamsi wants to come in because I named her.
Yes, on the subject of wish lists, something that's on our minds, but we know it's a complex problem that we're not going to be working on this right away, is how to make charts and graphs more accessible. And of course, at arXiv, that gets especially interesting because it's not arXiv staff generating charts and graphs. It's all these individual researchers who need to present all kinds of data in different ways. And yeah, very, very tricky problem. But I think the technologies that you've shared today are going to be part of the solution.
if there are accessibility problems relating to the output of TICs, and if these problems can be solved, or if there are no accessibility problems, that's even better. But if TICs produce any system that is widely used that produces accessible outputs, and we can make those outputs more accessible, is a big plus. And I think it's a big area to work on. And the pre-text people, the people that are doing accessible college level math books, are focused on this problem too. So I think that's a good area to focus on. So could you say it again, what you're concerned that the community, what you'd like the community to solve for you is, what it is you'd like the community to be able to do? Can you remind us?
Oh, what an interesting question.
Well, I'm just asking you to say again what you said before.
The end result that we want is accessible charts and graphs in the HTML representation of the paper that arXiv will host.
Right.
Are the charts and graphs actually written in HTML, or are they static images that are being pulled in to a rectangle that's reserved in the HTML page? I'm a little confused on that.
You're muted again.
I think right now people use a wide variety of languages and techniques to generate their charts and graphs. And maybe part of the solution is not for arXiv to dictate, but the academia as a whole might hone in on techniques that lend themselves to accessibility more than others.
I noticed something that surprised and to a certain extent pleased me, which is that if you submit an article to the mathematical part, at least of the proceedings of the National Academy of Sciences, they require you to submit the tables and charts and that sort of thing as separate files. Mm. And believe it or not, just the act of separating a chart out of separating a table out of a LaTeX document is a non-trivial task. And once they are separate, once they're available as separate items, it becomes much more sensible and possible to do accessibility audits. So maybe a useful step forward would be a tool that downloaded a paper, the source of a paper from the arXiv, and built it successfully and gave an accessibility report on that paper. That might help mobilize the forces that you're hoping to get a result from.
It is that scoring things is a really interesting topic. There are issues with that because it's not easy to measure accessibility, and what could be accessible to one person is inaccessible to another person. So we've been given some healthy warnings about the dangers of imposing our own scoring. But I do think that's an area for exploration. And I also really like this direction of providing underlying data. In our research, one thing that we heard frequently from users with disabilities is that if they can get their hands on the underlying data in table format, say, then they know what to do to understand that data. They can parse it, they can get the results that they need from that data that they can't necessarily get from the finished, maybe beautiful looking chart that the author might render from that data.
I think implicit in what you're saying is that you can't achieve the accessibility you want without engagement with the community.
That's well put.
Thank you.
I'd like to just toss in a comment about PIC for those who haven't actually used it. Brian Kernighan developed it in the 1980s to solve a problem that's fairly common in computer science of drawing little boxes and arrows between them and labels on the boxes and so on. And the beautiful thing about PIC is that you almost never specify anything to do with sizing or actual positions. You simply say, I have, say, 3 boxes. I'm labeling A, B, and C. I want a curved line from the northwest corner of box A to the center of box B, and a straight line from the edge of box B to the edge of box C. Now, the way I've described that is pretty much how PIC input looks. And if you were to have an audio reading of that PIC figure, at least for simple pictures, those would be quite understandable by people with visual limitations. Now, obviously, for more complicated things, when you've got dozens and dozens of boxes and lines going everywhere, it becomes a horrible mess. But for many simple things, PIC might be a very good choice, and arXiv might consider whether there's enough commonality of simple bar charts and pie charts and so on and box charts to encourage the use of PIC descriptions, as opposed to ones where you actually move to a position on the page and make a line of a certain length and so on.
The relationships that PIC is dealing with are not numeric relationships. The length of the lines, the position of the lines doesn't matter particularly. And that allows the declarative approach to be extremely useful and extremely powerful. And I think that's nicely put, Nelson, that there's certain data which has an underlying form that could be verbal. And the graphical form, if you like, provides a certain convenience for dealing with that data. And so this goes back to allow multiple renderings, including user-controlled, user-defined renderings. And when I say user-controlled, I don't mean you can make the letters bigger if you want to, but you can say, I'm going to take the underlying data and I'm going to render it in the way that I want to render it. Even though those capabilities might not be very widely used, they will open the door to innovation, I hope.
So when you're debugging an app on the Mac, as I do, the debugger has the ability to take your user interface and re-render it in 3 dimensions as a stack of the rectangles, the views that are nested and the views that are clipped and so forth. It's extremely helpful. So the thought occurs to me that for charts, there's probably some sort of organizational structure that allows different types of information to be in different layers. And each layer is simple enough that you could convert that to an audio description of what's going on, and maybe a person who's blind or so forth could go through the different layers, and one layer has the data points, another layer has the approximation curve, another layer has the axes, another layer has the labels. And so instead of having this jumbled, flattened set of graphic elements, you could have a blown up 3-dimensional view of it that you could that a blind person could browse through and have a much clearer understanding of the different relationships. Anyway,
to a certain extent, what we're talking about is data visualization, except we're not using the word visualization necessarily. We're talking about the looking can be such an active activity.
Multimodal perception.
Oh, wonderful.
I like that for comprehension
of data. That's so that's very much a user experience thing. And at some point, I feel that the people amongst us that have got the same vision as we have, but have the same intellect, would be very, very valuable here.
Yeah, but what you need is a lot more time.
Well, we need time, we need resources. We make the best with what we got.
There was an interesting example. I think it was from Samshi's research, but there was a person who listened to time series. Is that from yours?
Oh, that's right.
Yes.
That's right.
That was a really clever way. So someone who couldn't see, but when they wanted to understand time series, they worked out a way to play audio, turn that time series into an audio wave that they could listen to, so they could hear the series moving up and down over time just by changing the pitch. So it was another way to comprehend the history of some price index or something.
Yeah.
I thought, oh, that's neat. We should make hooks for that kind of thing, so it's easier to put that in there. And could there be some way to look at a point cloud through sound? That's something that's really, it's hard to, that sort of defies the explanation, I think, when you have a cloud shape, but you'd like to characterize what it's doing, like that somehow it makes a crescent shape. And giving some other way to interpret that would be great.
Yeah, Christopher, that's something that I know NASA is very interested in. Audification of images of space or data that's coming back from their telescopes.
Interesting.
I don't know quite how they're doing it, but they have intelligent minds working on that.
There's two things that come to my mind. The first is that a good automobile mechanic can listen to the engine, listen to the car, and know that there's a problem, and know where the problem is. And the second thing is that doctors do the same with the stethoscope, which and I think that's still true, very true today, that the observation of things. But I think that the auditory perception of data is quite different from the visual perception of data. There's something different going on for me when I hear something and when I see something. There's certainly different parts of the brain, aren't they? And when we know that a lot of our perception, our visual perception, is actually manufactured in the brain. It's not like a photograph, if you like. And there must be stuff going on in auditory perception. And I know that if you're a bird watcher and you get to understand the sound of a particular bird, you'll recognize it or just hear it. Just as you hear your name very clearly in the background noise of a cocktail party. So next week, my task is to compress 100 hours into one, or at least try and make a list of the titles and something about what we've done over the past 100 or so tech hours. And I don't promise to get any videos up apart from the most recent ones, but it's been a couple of years and a lot has happened. And I think we've settled into something quite useful now. But I also think it's time to, so to speak, branch out a little bit. And one of the things that's happening is that the 2023 Tech Conference has been announced. It's going to be in Germany. I think it's going to be in June or July, and it will be an in-person conference with an online element. So that's quite interesting. And I hope that some of the lovely stuff we've done in the meetings here will see itself again in a larger audience at the Tech Conference. So I'm finished. Anyone else want to make a closing remark? Please. Doug.
There's one little fact that I found out about a week or two ago, which is that upcoming Apple operating systems that come with an app they call Preview will no longer interpret PostScript. They'll show PDF files, but I've always used Preview to convert my EPSF files into PDFs. But Apple's getting away from that, I guess, for security issues or because it can be, PostScript can cause an infinite loop or something. But so that's a little piece of something you said earlier.
We need a clearinghouse for this sort of information, I think.
I'm really surprised that the PostScript expertise is so low that people fear it won't be maintainable anymore.
This is what I read on the GhostScript page.
Yeah.
Oh, is it?
I mean, there's compared to, I mean, I've been using PostScript for almost 30 years, but, compared to then, there's so much more today, so many communities, so many programming languages, packages, whatever, with, huge communities on GitHub and wherever supporting it. And, I remember a colleague back in the, late 80s, early 90s with the PostScript cookbook. He wrote an interactive Fortran program for making graphics in his spare time, and so really one guy, right? One guy, he actually started programming with punch cards. So, it was stone knives and bearskins compared to today. So it really surprises me that this expertise has sort of vanished.
I don't think it's vanished.
Or the people are getting old. Or what's
according to what I read on GhostScript, it's a concern. And so it's not a primary motive, it's a tertiary motive. But it is a motive all the same.
Mm.
And it's certainly something we should be aware of when we're thinking about the graphics we're writing now and their use in the next 20 or 30 years.
Does anyone have any idea what percentage of PDF is produced from PostScript?
Sorry, could you say that again?
What percentage of PDF is produced from PostScript?
It's probably small now.
Yeah, I would say it's small and getting smaller because many users have switched, say in the tech community, switched to using PDF-Tech or ZTech or LuaTech directly.
Yeah, exactly. Yeah.
Use PDF without any PostScript there.
But most PDF probably doesn't come from tech, though.
Well,
no, but the one of the main problems for PostScript developers is that it's an extremely easy language to parse because it's defined in such a way that when you pick up an object from the input stream, you push it onto a stack, and you keep doing that until you get to an object that's an operator, and that operator knows how many operands it's expecting and pops them off the stack, does something, pushes a result back. Now, if everybody were totally disciplined, this wouldn't be much different than calling a function with arguments A, B, and C. You'd say function ABC in a programming language that's more traditional, and in the PostScript style, you would write ABC and function name. Unfortunately, what has happened with both PostScript and also with BibTeX style files, which also have the similar kind of language, is that those things being pushed onto the stack can be pushed at different places in the program. And it can be extremely difficult to figure out when you get bad arguments to a function, where did they come from and why are they wrong? And so I think that has meant that programmers did not develop a lot of enthusiasm for using PostScript as a straightforward programming language. Our colleague Bill Castleman, who's a visitor here fairly often, has written a very nice book on doing mathematical illustrations of PostScript. But by and large, I think Ghost Artifacts, which is the company that provides both GhostScript engines for printers as well as making the free version, they were faced with the problem that the complexity of new features in PDF was such that trying to keep them debugged in a PostScript representation and also performing efficiently was just unmanageable. And so they, about 2 years ago, they began rewriting the interpreter for those things entirely in C. And with GhostScript version 10, they've switched to that. from their point of view, it was kind of self-defense. They simply couldn't proceed because the complexity was becoming unmanageable.
In response to, that's really helpful, Nelson. It's given us a lot of background, given me a lot of background about the move away from PostScript and why it's happening, and whether we like what's happening, it's certainly very helpful to understand what's happening.
I can, for those of you who want to probe further, just do web searches for gs-devel. That's the GhostScript development list and the TechLive mailing list. The TechLive list has had a fair amount of correspondence in recent months about this problem of GhostScript dropping certain features of PostScript. And the GS-devel list has lengthy contributions from people at Artifacts explaining why they felt they had to make this decision.
To answer Philip's question, today I printed out the web page for the Tech Hour so that it was in front of me. I reckon that when I printed the web page in my browser, the browser created PDF and sent it to the printer.
Yeah,
That's a PDF
probably.
file that didn't last longer than a minute. Well, I'm going to stop recording now. I'm very grateful for everybody coming. I think we had a really useful discussion and we've moved forward, although I don't know quite exactly where we are. I think that the problems that the archive are dealing with are really important for understanding what goes on with graphics. And I await their report with bated breath. I'm really grateful, Doug, for you sharing and demonstrating your space filling curves, and for Nelson for sharing the early history of Adobe, and for everyone else for coming along and contributing.
Yeah, it's very interesting. Thank you.
Can I add one little item to the history?
Go ahead.
The precursor to PostScript was a language called JAM, J-A-M, which stood for John and Mark, where John was John Warnock, and it was at Xerox PARC. So I actually have the manual for it, which I got when I made a visit there in the early 80s, right before John Warnock left to form Adobe. And I'm going to have to go look at it because I think it might have also had spline-based curves in it, and they were doing maybe some fonts with spline-based curves, you know, pre-Adobe in that language. I'm not quite sure. So just.
And can I just say something, Doug? That manual that you're going to have a look at, is it printed on paper?
It is indeed, and
And you still have it?
I have some prototype laser printer output from 1978-79 that Bill Gosper did at Xerox PARC. I guess it was 1979. He also is a space filling curve aficionado and discoverer. And you can feel the ink on the paper. It's that thick. It was really, you know, low resolution and very. It was almost like, I mean, you can rub your finger along these printouts and you can feel the lines. So that actually is a good idea for accessibility if you think about it.
Well, at least you know which side the paper is printed on.
That's true too.
Well, thank you all for coming, and if I don't see you again, have a good Christmas and a lovely New Year.
You too.
You too.